Hello, so in today's class we will look at the next property of Laplace transform. So the next property is L of fx by x is given by integral p to infinity f of s ds. So let us prove this. For proof we'll start with the left hand side of the equation. So you have integral p to infinity f of s ds. So that is integral p to infinity. Now by definition, this function f of x that denotes the Laplace transform. So that is integral 0 to infinity. ഇപ്പോൾ ഞാൻ പാരാമീറ്റർ s ആയിട്ടാണ് എടുത്തിരിക്കുന്നത്. അപ്പോൾ e raised to minus s x വരും into f of x dx. So this is the value of f of x. Then you will have ds. And now let me change the order of integration. So when I change the order of integration, so we will get integral 0 to infinity. So the second integral will be with respect to x. So first integral with respect to s. Okay. So f of x will come out of that because that is independent of s. So you will have integral p to infinity e raised to minus sx ds dx. Now that will be integral 0 to infinity f of x. Now this integral will be e raised to minus sx by minus x varum from p to infinity dx. So that is integral 0 to infinity f of x by minus x. Now upon applying the limit e raised to minus sx in the limit e raised to minus infinity varum 0 minus e raised to minus s nana apply cheyunappo px varum dx. So that is integral 0 to infinity. So here minus sign will cancel off. So you will get fx by x e raised to minus px dx. So we started with integral p to infinity f of s ds, that is equal to integral 0 to infinity f of x by x e raised to minus px dx. So you can see that this is the Laplace transform of fx by x. So that is the required result. So Laplace transform of fx by x. So if you know the transformation of Laplace transformation of f of x, then that is integral p to infinity f of s ds. So let us see an example. So we use the fact that L of sin x is equal to 1 by t square plus 1 to calculate integral 0 to infinity sin x by x dx. Now integral 0 to infinity so we need to find integral 0 to infinity sin x by x dx. Now this will be given by integral 0 to infinity f of x by x e raised to minus px dx. So this is the Laplace transform of sin x by x. So that is given by integral p to infinity f of s ds. അപ്പോൾ നമുക്ക് ഇവിടെ p യുടെ value 0 എടുത്താൽ മതി. So take p value equal to 0 here. So that will give integral 0 to infinity ini f of s ds varum. So that is integral 0 to infinity f of s ennu parayna 1 by s square plus 1 ds varum. So that will be tan inverse of s from 0 to infinity. Now tan inverse of infinity is pi by 2, tan inverse of 0 is 0. So the required value of integral will be pi by 2. So that is how we use the property. Now let us look at few more problems. So we need to evaluate these two integrals. So first one is integral 0 to infinity e raised to minus ax minus e raised to minus bx by x dx. So we will use the result integral 0 to infinity f of x by x e raised to minus px dx is equal to integral p to infinity f of s ds. So that implies integral 0 to infinity f of x by x is equal to integral 0 to infinity f of s ds. This is the case when p is equal to 0. So therefore this integral will be equal to, so this is in the form 0 to infinity f of x by x. Now L of e raised to minus ax minus e raised to minus bx will be equal to 1 by s plus a minus 1 by s plus b. So 1 by, p plus a, p plus b. So therefore f of s will be equal to 1 by s plus a minus 1 by s plus b. So therefore integral 0 to infinity e raised to minus ax minus e raised to minus bx by x dx will be integral 0 to infinity 1 by s plus a minus 1 by s plus b ds. So that will be ln of s plus a minus ln of s plus b from 0 to infinity. So that will be equal to ln of s plus a by s plus b from 0 to infinity. So let us take this as limit. Say some x tends to 0, x tends to infinity, ln of x plus a, s plus a by s plus b from 0 to x. Okay, let me take some other value instead of x. So let me take it as some c. So upon applying the limit, it is limit c tends to infinity ln of c plus a by c plus b minus ln of a by b. So that will be equal to limit c tends to infinity. This will be ln of 1 plus a by c, 1 plus b by c minus ln of a by b. That will be equal to limit c tends to, okay, when you take the limit c tends to infinity, you will get ln of 1 minus ln of a by b. So that is minus of ln of a by b, so which is equal to ln of b by a. So that is the required value. Next we need to find integral 0 to infinity e raised to minus ax sin bx by x dx. So this will be in the form integral 0 to infinity fx by x e raised to minus px dx. So you will get integral p to infinity f of s by f of s ds. Now let us calculate f of p. F of p will be the Laplace transform of e raised to minus ax sin bx. L of sin bx is b by p square plus b square. So now you have e raised to minus ax, but p will be replaced by p plus a varum. So you'll get b by p plus a whole square plus d square. So integral 0 to infinity e raised to minus ax sin bx by x dx will be equal to integral 0 to infinity b by s plus a whole square plus d square ds varum. So this is equal to tan inverse of s plus a by b varum from 0 to infinity. Now at infinity, tan inverse infinity is pi by 2. So minus tan inverse of a by b varum. So that is equal to cot inverse of a by b varum. So which is equal to tan inverse of b by a. So that is the value of the required integral 0 to infinity e raised to minus ax sin bx by x. Now let us look at the next property of Laplace transform, that is called convolution property. Now if you have, so let f and g be two functions. So they are defined in the interval 0 to infinity. Then the convolution, by convolution we mean, so that is denoted by f star g. So then the convolution of functions f and g is defined as, so that is a function f star g of x given by, so that is integral 0 to infinity 0 to x f of x minus t g of t dt. This integral is called as the convolution integral, and let us now look at what is the Laplace transform of the convolution of two functions. So L of f star g of p, so the Laplace transform of convolution is given by f of p into g of p. So this is equal to the Laplace transform of f of x into the Laplace transform of g of x. So if you have a convolution of two functions, so that is f star g, then the Laplace transform of f star g will be the Laplace transform of f into the Laplace transform of g. So let us look at the proof of this. And again we will start with fp into gp. Any other f star g യുടെ Laplace transform ആണെന്ന് നമുക്ക് കാണിക്കാം. So let us start with f of p into g of p. So that will be equal to integral 0 to infinity. So by definition that is e raised to minus px. So let me give the variable f of s ds, and the second integral is 0 to infinity e raised to minus, sorry, p, the ps. Okay, so let me take it as pt here, f of, no, g of t dt. Okay, so g of t dt. Now let us combine the two integrals, so that is 0 to infinity, integral 0 to infinity e raised to minus p s plus t. Then you have f of s g of t ds dt. Now this can be put as integral 0 to infinity, then integral 0 to infinity. So this is e raised to minus p s plus t f of s ds. Then you have g of t dt. And now this is in the form of an integral in the form of Laplace transform. So